For 4.3, the main idea is trying to figure out how accurate your model is. Like when we do the regression, we do the best fit line, we want to know how good is it. So we're gonna look at the statistics and information, also certain types of scatter plots to figure out is this good. So let's start with some definitions first. Let's see here. All right. The coefficient of determination is r squared. And I think we've already calculated that on Excel. Remember, it gave us the r squared. We didn't talk about it, but we're going to do that now. It's called the coefficient of determination. This measures the proportion of total variation in response. I'm sorry, variation in the response. Variable. That is explained be cool if I abbreviate least squares regression. I'm getting tired of writing that. LSG line. And we've written that enough. Personally, in stats, we just call it regression. We don't say least squares, but the book does. That's fine. Okay. Just a quick note here. R squared will be measured between 1 and 0. So the closer it is to 1, the better. That means it's explaining 100% of the variation in the response variable. Yeah. Okay. Is equal to 0. Let's make a note here. If R is equal to 1 or close to it, then the least squares regression line explains 100% of the variation in the response variable. If R is equal to 0 or close to it, then the LSG line has no explanatory value. So just in plain English, the coefficient of determination is a measure of how well the least squares regression line describes the response variable and the explanatory variable. Okay. So the better the R value, closer to 1, the better that explanation of that relationship. Okay, the X and Y explanatory and response. But you want it to be closer to 1. That's what you want. Otherwise, it's a crappy model. It's not describing of your relationship. Is that clear? Okay. Let me find a picture of that. Let me see if I can. I'm not gonna make you calculate R squared by hand, just like I did in R. And your okay, here's a good example. In one moment. Need to share it on the. I need to share it so I can record the pictures. Okay. Can everyone see the lines? Okay, so notice how all the data points are right on the line. That's pretty good fit, right? Now, this would be your model, your white hat. You would put in some data regression to get out line. This is the equation to that one. The site back in the day, apologize for the slope intercept. Here's another one, but notice how the data points a little bit more spread out. Here's that line. This one doesn't look like a very good fit, right? It's pretty spread. Now, if you were to look at the R squared for each one, you can see how good the fit is. So check it out. So for line ABC, data set ABC, that first line, R squared value is really close to 1. In other words, 100%. B was pretty decent. It was pretty good, 94, but C was garbage. Low percentage. It's close to 0. Right? That would be what 0.94, right? Does that make sense on what the R squared tells you, what it means? Okay. That makes sense and cool. Let's keep going. Okay. Let's talk about residual plots. So if a plot of the residuals against the explanatory variable shows a discernible pattern. Such as a curve. So if you see like the residuals having like a kind of a curving pattern, well, any kind of pattern, you see something. Then the explanatory and response variable may not be linearly related. Thank you. So if you do a scatter plot of the residuals, but if a plot of the residuals against explanatory variable, I've got my y in there, shows a discernible pattern. So if you see some sort of pattern when you plot the scatter plot for residuals, any kind of pattern, then that might be that hint that your x and y are not linearly related. Okay, does that make sense? The residuals tell you. Because you can, when we did the Excel, remember we had an option, check the box and said plot the residuals. So we can do that and check out more information on your model. Okay. Okay. Let me show you a picture in just a moment. From your book. Right. So notice, so here these are the residuals. So they already put the data in data regression. You can check the residual box. Okay. You can give it a base. But you want to see no pattern. You want to see patterns, madness. Okay. That's what it is. So then your model is good. It's broken. You can kind of see a very little pattern. Like, oh, maybe it's parabolic shape or this curve down there. You see what I'm talking about? That pattern is telling you that yeah, you know what, linear model is not good with this data set. You might be another model that's good. This data can be modeled by different types of functions. Right? Doesn't have to be linear. But we're studying linear right now. So you see anything like that? Not good. Okay. Is that clear? That's what we said in words, and that's the visual. Okay. This next part is about the variance of residuals. So if a plot of the residuals against the explanatory variable explanatory variable shows the spread of the residuals increasing or decreasing. As the explanatory variable increases, then a strict requirement of the linear model is violated. This requirement is called constant error variance. This requirement is called constant error variance. Okay, so let's get a visual in just a moment. So the homer is going to give you scatter plots, like I just showed you earlier. It's going to ask you, okay, is this thing linear? Is it not linear? Is it a good R square? And then they'll ask about constant error variance. So if you see the pattern kind of like increasing, just go down or decreasing, then it's this type of error. Let me find an example. Yeah, here we go. Let me share the screen. This is the example they had before. They have this model. That's good one. You see the graph, it looks like it's good, right? You see the individuals. You notice that as the text that we find where the data is spreading out. This pattern showing the variance increasing because it predicts this model. It's not very good because it starts to have too much variation after about 4. That makes sense. A lot of we kind of see it here, right? The data points kind of spread out as well. There's more variation at the end, which is represented by the residual plot. So it's not a good model. It's okay, but it can't really predict too much into the future. And kind of misses the points, right? Like if we're trying to predict cells or whatever, doesn't matter what it is. Okay. Are there any questions on those ideas? I know it's Monday, but okay. Okay. Let's talk about outliers. Yeah, this is an idea. When we have our residual plots, we might have a couple of plots that are extreme, a couple of data points. We call those outliers, which we found in the box plots, remember? I think it's in chapter 3. So we can still find them using box plots. So what you can do is whatever data we're talking about, run the box plot through it, find out what is the outlier, and remove them. If they are removed, then your linear regression will improve. The residuals will lose that widespread, but it'll be better. So there might be questions, at least for sure, if we were doing experiments or something, that would be something we'd do. We'd analyze data, see if there's any weird points, remove them, and improve the model. Okay. So let's look at the homework. I'm trying to find a picture though. The last thing we'll talk about, let's do some homework. Here, so in the book. So here's some random data. Here is a residual plot of that data. Notice how the outlier kind of has a weird point for the residual. So removing this guy will improve the model. You have this line here, right? So if that's removed, that means the actual improvement R will be better, and so will the R, right? Lowercase r. Right. Same thing here. I don't see any pattern, but this makes me think that if I want to violate that error variance, spreading out like crazy over here. That might be an issue. So if you do the box plot, we can find out what the point is. Might be some strange occurrence, and you can justify it, you can remove it. Anyway, so start 4.3, please. No, but I don't know what the date is. What does it say? Technically, there's an auto extension, but since we just talked about it, I'll probably move it a little bit. But technically, it's open until Wednesday, as of so far, but I'll change it to Friday. So question 3, do you see what's wrong with it? What's wrong with the residuals? Yeah, it starts to spread out, right? Which is the we call the constant error variance, right? Now, if I click it again, I'll get a different one. Here, I don't see any issues. I think it might be fine, right? No issues. Here we see a pattern, right? Also, it's spread out and then coalesces, so it's the same problem. Okay, so just think about those ideas.